Welcome to qnawire.
Problem 736. A marble moves along the x-axis. The potential energy function is shown in figure 736, at which the labeled x-coordinates is the force on the marble 0. So the x-coordinates we have available here are A, B, C, and D. So first off, what does it mean by having the force on a marble be 0? So in the context of potential energy, remember we have an equation that tells us that the force on a particle at a certain point is equal to negative the derivative of the potential energy of that variable. Okay, so that means that wherever we have the slope equal to 0 is where we're going to have the force on the marble equal to 0. And so in order to tell that on a graph, that's the point where it's horizontal. So that's going to be at points B and D. Okay, which of the labeled x-coordinates is a position of stable equilibrium? So stable equilibrium again means it's the potential energy is horizontal. However, stable is different from unstable in that the force pushes it towards that point on either side of that point in x. So what we do is we need to find what the force is on either sides of these points of B and D and figure out if it's stable or unstable equilibrium. So negative derivative of potential from A to B. Since that slope is negative, the force is going to be positive. From B to C, the slope is positive, so the force is going to be negative. From C to D, the slope is positive, so the slope is going to be negative. And from D on, the slope is negative, so the force is going to be positive. So we see if we have a marble here at point B, if it moves off to the side a little bit, the force will push it back. It moves off the side here, the force will push it back. But here at point D, if the marble moves off to one side, you'll get feedback, reinforced feedback that will push it further away. So the only stable equilibrium here is going to be at point B. Which of labeled x-coordinates is a position of unstable equilibrium? So that's the same discussion I had before, and that's going to be at answer D.